All right, ladies and gentlemen, so we're diving into the last section. Try to do this quick for you, get you out early. But the faster you answer questions, the faster we can go. If we're going to sit here for 5 minutes on questions, then we're going to be here longer. So you guys got to help me out. Turn those mics on, help me out, especially when I call your name. So here I got chapter 2-3, day 1, properties of functions. We're going to spend some time on day 2 on Tuesday. Then we'll review on Tuesday and get you ready for the quiz next Thursday. So a week from today is your next assessment. We have goals. Use a graph to determine whether a function is increasing, decreasing, or constant. Use a graph to locate local max and mins. Goal number 3 we're going to do on Tuesday. And today, goal number 4, determine even and odd functions from a graph or equation. So as you take a look, this is what the textbook says what increasing is. Okay, it says a function f is increasing on an open interval I if for any choice x1 and x2 in I, with x1 less than x2, we have f of x1 is less than f of x2. And I just read that, and I bet nobody probably understands what I just said. So this is why Mr. Gotsch gets the big money, okay? This is why I make millions of dollars doing this. When you read it, this just means from left to right, the y's go up. That's essentially what increasing means, okay? When we look at graphs, we want it to go up. Decreasing goes down to the right. And then constant. So when we're looking at constant, that just stays equal, so it just goes across like that. Okay, so you need to know what increasing looks like, you need to know what decreasing looks like, and you need to know what constant looks like. We always read graphs left to right. Local max occurs when the graph of the function is increasing from the left and decreasing from the right. It has to have both increasing and decreasing, so it has to look like a mountain. Okay? And then the very top of the mountain is my maxima, or my max for short. So it's got to have both parts. It's got to go from increasing to decreasing. Okay? Next, the absolute maximum is the largest value of f. So if they want the absolute max, it's the highest mountain. So if you have 2 mountains, this is the absolute max. These are both maxes. This guy and this guy is both a max, but this one is definitely the highest. Okay? Minimum occurs when the graph of the function is decreasing from the left and increasing from the right. So that's the bottom of the valley. Okay? So that would be a min. If they want to know where is it at, if they ask where is it, it's the x value. So if they say, hey, where is the mins and maxes at? They're just asking you to list the x value. If they ask you what it is, that's the y value. So make sure you know that. Where is the x value? X marks the spot. Where is my treasure at? That's x value. What is the treasure? That's the y value. All right, so we're going to take that same graph that we saw in chapter 2.2, and we're going to go look for increasing values. Now, intervals means we're using interval notation. And we always use parentheses when we're using interval notation for increasing, decreasing, and constant. So I look at my graph. I follow it. Increasing, I'm going to do in blue. Okay? So I follow my graph. It's like a roller coaster. I'm going up. That's increasing. Where am I going up? Remember, where is the x values? I'm going up from 0 all the way to 2. It's going up. So I would say 0 to 2 in interval notation, it's going up. Remember, we're only looking at x values. Now, it might be helpful. I know you can't do this on a computer screen. If you're taking notes, printing my notes out, it might be helpful to highlight the X values because that's all we're listing for increasing, decreasing, and constant. Okay? People who get this wrong, they say, well, it's increasing from 0 to 1 and then 1 to 2. They list both of those intervals. Well, it doesn't stop between 0, 1, 1, 2. It's going increasing the whole time. So tell me the whole way. Okay? Then we put our hands up on the roller coaster. Woo! Wee! Yeah, right there. That's all going down. That's decreasing. From what to what? From what X value to what X value is it decreasing? What do you guys say? Tyler, Anna, Adam, what do you guys say? What is the X values that it's decreasing? From what to what? Where's this thing going down? Can you guys see it? Can you hear it? 2 to 7. Fantastic. So up here at 2, it switches gears from increasing to decreasing, and it goes down. It goes down. It's yelling timber. Then the roller coaster ride, we start going up, up, going up, going up. Going back to blue, going back to increasing from 7 to 10. So 7 to 10, it's increasing. My math lab, you can put a comma between those intervals. So 0, 2, the parentheses around comma, parentheses 7, comma 10, parentheses. And then last but not least, I'll switch to a different blue. It goes straight across. And that's from 10 to 15. So 10 to 15, it goes straight across. So that's my constant. So it goes up, increasing, goes down, decreasing, goes up, increasing, goes across. All right, you guys have any questions with that? All right, so increasing, decreasing, pretty easy. Make sure you're using the X values, not the Y values. I get the Y values a lot. They'll say, oh, it's increasing from -3 to 3. Those are the Y values. Well, look at your graph. Between -3 and 3, it goes up, it goes down, it goes up, and it stays across. You can't use Y values to tell me what's going on with the height of the graph. That's the X values. Okay, so if I'm talking about height, I got to know where's that happening. That's the X values. All right, next one, list the maximum. List the number at which F has a max. What are the maxes? Remember, it has to have a mountain. It has to go from increasing to decreasing. I have to have blue to red. And there's only one place where blue to red happens. And that's right here. From blue to red, this right here is a maximum. Where is it? That's the X value. What is it? That's the Y value. So 2, -3. On a quiz or test, I would be totally fine if you just gave me the coordinate point. If we were in class, we're taking the test in person, we go back to hybrid, I'd be fine with that, a coordinate point of -2, 3. Minimum where it goes from decreasing to increasing, where it goes from red to blue, okay? Increasing to decreasing. Here it is, decreasing to increasing right here. This guy right here is the minimum. Okay, so where is it? It's at 7. What is it? -2.5. Or if you just gave me the point 7, -2.5, that would be fine for me. Okay, so that happens right there. Now, I always get the question, well, Mr. Gotsch, isn't 0 -3? Isn't that a minimum? And I have to say, no. Why is this not a minimum? What's missing? This is a minimum. Why is this one not a minimum? What do you guys think? Yeah, there's nothing on the left side. It has to have the decreasing part. If it doesn't have anything over there, it's not technically a minimum. It has to have both parts. Okay? All right, that was easy. Any questions, y'all? Any questions with increasing, decreasing, constant? Tap your head if you got this. Tap your head. This is easy, Mr. Gotsch. Let's move on. All right. Lots of taps. Goal number 4, even and odd functions. Even and odd functions. Odd functions is symmetric to the origin. We have symmetry about the origin. Now, if you ever forget, look at the most famous odd function, y equals x cubed. If I plug that in the calculator, you will see an S-curve like this. That is an example of an odd function. Okay? It is symmetric to the origin, so what's over here is over here. X comma y is on the graph, and negative x, negative y is on the graph. Okay? Even function, symmetric to the y-axis. Okay? Take the most famous y equals x squared, the most famous even function, the parabola, and graph it. It's got even exponents. 2 is an even number. And you see a nice pretty graph where it has the point xy and negative xy. Okay, it's symmetric to the y-axis. So if you ever forget, odd, graph y equals x cubed, that's an example of a odd function that's symmetric to the origin. Even, just graph y equals x squared, oh yeah, it's symmetric to the even y-axis. Okay, or I always remember OO, odd origin. They both start with O. Okay, so you're going to be asked to look at these graphs and identify if these guys are even or odd. Now, it does say algebraically verify the conjecture of did you decide if this is even or odd. You do not have to do that. All you got to do is yes or no, is it even or odd? Okay, so what I would do is I would just throw these in my calculator. Number 1, there's no way this thing's odd because the exponent is even. So my question now, is this an even or an odd graph? Well, this is probably even. So let's see. I've got negative x squared plus 9. And I can zoom in a touch here so we can see that. I graph it. I'm in zoom 6. And I see a nice looking graph here. If I want to be very technical, I could look at the table or second trace value and plug in like 0, and I get positive 9, and so on and so forth. I'm just getting a rough sketch for notes, and this one is clearly symmetric to the y-axis. So this is definitely an even function. I'm just graphing these real quick so we can get you guys off Zoom. Same thing with this one. This is potentially an odd. I have x cubed over 25. So I graph it. I have x raised to the third, get out of there, and then divided by 25. So I graph that. And I'm just going through this quick. And yep, that definitely looks like it's symmetric to the origin. If I want to verify, I could go second trace value. I could plug in 3 and see what I get, or plug in 5. And I get 5, 5. And when I plug in negative 5, I get negative 5, negative 5. So it is definitely symmetric to the origin. So again, I'm just doing a rough sketch. That is definitely an odd function. Okay, so this one's even, that one's odd. Next one, absolute value of x. Some of you guys don't know where absolute value is, so I make sure I show you that. So I go to y equals, press the math menu. So press the math menu, go over to number, N-U-M. ABS stands for absolute value. If you have an 83, it's going to stay ABS, and then just plug in X. And then there we go. We get the cheerleader function. Looks like this. Looks like a V. This one is definitely an even function. It's symmetric to that y-axis. Last but not least, we got the inverse function. We got -1 over x. So I'm going to type that in. I have the negative below the 3, 1, and then divided by x. And I'm going through this quick, so hopefully you're paying attention. I look at this graph here, it's in blue. I look at this graph here in blue. That one is definitely symmetric to the origin. Okay? So that is definitely an odd function. So I've given you some examples. If you don't see that it's symmetric to the origin or to the y-axis, then it's neither, even or odd. Okay? So all you have to do, plug these in your calculator, look at them, and you should be able to verify easily whether it's an even or odd function. Is it symmetric to the origin? Then it's odd. Symmetric to the y-axis, even. All right, ladies and gentlemen, last but not least, average rate of change. Average rate of change. We want you to think slope. Okay, if I want to find the average rate of change of something, I'm thinking of the slope of something. Now, when you look at this, the change in y over the change in x, this is just slope formula. Okay, back in the day, we talked about the picnic table, the margarita glasses in chapter 1, and then you got to be 21 to drink. Subtraction in between. Well, this formula here is this formula here. They're the same. This is in function notation, and this is in nice pretty notation with y's and x's. Okay? So what we have here is they have 2 coordinate points of a function. They're saying, hey, can we find the slope of this secant line that goes through those points? Well, this is, again, this is my x2, y2, and this is my x1, y1. And all they're doing is they're doing y2 minus y1, or in their case, f of x minus f of c, all over x2 minus x1. They have x minus c. They're using different letters. Instead of x, they're using c in this point, so you can tell them apart. Okay? So how do you do this question? Find the average rate of change. Again, find the slope. When you see average rate of change, you just want to know what the slope is of that function. The function we got is right here. I've got x squared plus 7x. They want you to compute the average rate of change from x equals 1 to 2. Well, what they're saying is they want the slope from 1 comma something, question mark, to 2 comma something. So they're giving us the x values, and they're not blatantly saying, hey, well, what's the y values? If they gave us the x's and the y's, then slope is really easy. Well, how do I find the y values is my question. I've got my function. I got my x values. How do I find the y's? Because that's the first thing we got to do. What do you guys think? How do you find the y values given x's in the function? What do you think? Nolan, what do you think? Emma K, Faith, Emily K, what do you guys think? Lindsay, how do I find these y values given a function and x values? What's that? We're going to use the slope formula in a minute, but we don't have the y's yet. How do we find the y's? That's my question. We are going to use slope formula. That's good. We can't do it yet until I find the y's. We got x's. Ding, ding, ding. Yeah, buddy. Remember, f of x is the same thing as y equals, right? So if we can plug in 1, if we can plug in 2, we'll find the y values that correspond with 1 and 2. So first we got to find f of 1. So we plug in. We got x squared plus 7 times x. We're going to plug in that 1, right? 1 squared is 1 plus 7 times 1 is 7. That's 8. So this guy here is 1 comma 8. Okay? And then we got to go off to the side and find f comma 2. Some of you guys are really good. You can just do this in your head. That's fine. I'm showing a little work for notes. So 2 squared is 4. 7 times 2 is 14. Add them up. That's 18. So now I have 2 comma 18. So if I want average rate of change, all I got to do is come up with the slope. Lindsay mentions use slope. So I got my y2 minus y1. I got my x2 minus x1. We plug it in. We got 18 minus 8. y2 minus y1. We got x2 minus x1. I got 2 minus 1. I simplify. 18 minus 8 is 10. 2 minus 1 is 1. So my average rate of change is 10. All right. This, ladies and gentlemen, is really the start of understanding the derivative, which is a calculus topic that we'll see at the end of the semester. Okay, trying to find how a function changes over time is slope. Trying to find out if you're talking about, a cost function was what is the cost as X values get larger and larger. As I start selling more bicycles, as I start selling more hot dogs, as I start selling more donuts, what's the cost? How is that going up at an average rate of change? Okay, I want to show you one more of those real quick. See if you can't do this one. Take 1 second. I've got a new function. I want to find the average rate of change. I've got x squared minus 4x. And now this time it's where x is 3 and x is 8. How do I find the average rate of change? So take a second. Find the average rate of change from 3 to 8. First thing you should be doing, David, is finding that y value. Once we have the y's, Jimmy, then we can plug it in to our slope formula. Always want to reduce functions if you got, or reduce fractions, excuse me. So if you can reduce, you should. All right, so real quick, when I plugged in 3, and I want to get you out of here, when I plugged in 3, I got -3. When I plugged in 8, I got 32. So when I plug this in, 32 minus a -3 is +3. That's 35. 8 minus 3 is 5. So final answer, 35 over 5, we should get a 7. That's our average rate of change. That's our slope. Okay? So that's going to be a quiz question. You got to know how to do that. I hope you have that written down on your notes. Again, you can use notes as we're taking quizzes and tests. So hopefully we're taking good stuff. Ladies and gentlemen, I am done with the first section of chapter 2-3. You guys have 2 assignments now, 2-2 and 2-3.